physics problem related to Snell's law, particularly calculating the critical angle and index of refraction. In the problem, a ray of light emitted beneath the surface of a known liquid with air above it undergoes total internal reflection, as shown below. For letter A, we need to calculate the index of refraction for the unknown liquid. For letter B, we need to identify the specific name of the liquid. Now, to answer this problem, first we need to analyze the given illustration. From the image that is provided, we can see that the X and the Y component of the light source is provided, which forms a right triangle. Therefore, to calculate the critical angle on this side, first we need to calculate the angle in this side of the right triangle. Remember, this side and this side of the triangle are said to be alternate interior angles. Therefore, once we calculate the angle in this side of the triangle, then we can identify also the critical angle. So the next step is to identify the components of the right triangle. 13.4 cm is the opposite side, while 15.0 is the adjacent side of the right triangle, since this is the angle that we need to calculate. So, for the given variables, Rn2, which is air, has an index of refraction of 1. The adjacent side, which is 15.0 cm, and the opposite side, which is 13.4 cm. For the required, we need to calculate first the index of refraction for the unknown liquid, and for letter B, we must identify the specific name of the unknown liquid. So, to proceed for the next step, we need to calculate the critical angle from the unknown liquid to air boundary. Our equation is to make use of the tangent function, which is equal to opposite divided by the adjacent. So we are getting the ratio between the opposite side and the adjacent side of the right triangle. Rearranging and substituting the given variables for opposite, we have 13.4 cm. For the adjacent side, we have 15.0 cm. Dividing the given variables, we have 0.893333. The next step is to get the inverse function of tangent for 0.893333, and the angle that we can calculate is equal to 41.78 degrees. Therefore, this is also equal to the critical angle. That's why we can say that the critical angle is also 41.78. Now that we have the critical angle, we can proceed to the next step, which is to calculate the index of refraction for the unknown liquid. For the equation, we can use the sine critical angle is equal to N2 over N1. So, rearranging the equation, we have N1 is equal to N2 divided by sine critical angle. Substituting the values for N2, we have the index of refraction for air, which is 1. The computed critical angle is 41.78. So 1 divided by sine 41.78 will give us 1.5. Therefore, the index of refraction for the unknown liquid is equal to 1.50. So, to answer letter B, we can proceed to the third step, identifying the specific name of the liquid. To answer this problem, we need the table of the index of refraction for several liquids. Analyzing their index of refraction, we can see that the benzene has an index of refraction of 1.501. Therefore, the unknown liquid is benzene.